Morning to everyone. This is third video of additive manufacturing. Here we are going to discuss about the AM process, that is binder jetting process, material extrusion process, and powder bed fusion process or sintering techniques. In the last class we have discussed about some of the AM process, that is photopolymerization and material jetting process. Binder jetting process. So this is one of the additive manufacturing process wherein we are going to use two materials, that is binders and metal which is in the powder form. We are going to use many materials like metal powder or polymer powder, or it may be the ceramic powder. So here there is a flexibility of using different type of powders in order to manufacture the 3D model. Here basically we are going to use the binder and the powder material in order to manufacture the 3D model. And this is the illustration of binder jetting process. Here in this process we will be having liquid adhesive supply, so which contains binder in the form of liquid, and this liquid is supplied to the inkjet print head according to the directions that is provided by the data. This inkjet print head can be moved in horizontal and vertical direction as shown in the figure. So you are observing the arrow marks. So this print head can be moved in X and Y direction on the build platform, and also at the bottom you are seeing the two containers. So that is, in the first container we are going to use the powder material, which may be either metal or polymer or ceramics, and in the second container, that is, we are going to build the 3D objects. That is, you are observing that there are three number of objects that are created here. So that is represented by bulk parts, and here there is a build platform which you can observe here, that the green arrow mark which is showing in a downward direction, this build platform can be lowered in a Z direction, and we are observing the leveling roller. So this roller is used to deposit the powder material, or it is used to level the powder material onto the platform. The working principle of this binder jetting process is that, first of all, as you discussed that, so there will be a powder material that is deposited in the first container, and there will be actuation system. So with the help of actuation system, the powder material from the first container is going to be lifted upwards, and after the powder is lifted upwards with the help of leveling roller, the powder is transferred onto the second container, that is it is transferred onto the build platform, which you can observe that build platform is just below, but this particular build platform will be on the top surface initially. After that, we are going to level the powder depending upon the data that is available from the STL file. After leveling the powder, then the liquid binder which is present in this particular container is going to be transferred to the inkjet printhead. This inkjet printhead is going to move on the surface of the platform in horizontal and vertical direction. So this is the movement of this inkjet printer is controlled by the data that is supplied by STL file, that is according to the 3D object that is to be manufactured. And now this inkjet printhead is going to deposit the binder material on the surface of the powder material as per the design of the model. Then after some time, it is not that the binder has to deposit throughout the surface of the powder. Depending upon the data, depending upon the model that is going to be created, and depending upon the slices how it is made, depending upon that the binder material is going to be deposited on the surface of a powder, and this powder is going to bind within a fractions of seconds. After binding the powder particles at particular places on the build platform, this build platform is then lowered to a distance of the thickness of the powder that is laid on the platform, and again the process is continued. Again the powder material from the first container is going to move upwards, and again the powder is then transferred to the build platform using the leveling roller, and again the binder is going to be deposited on the powder material of certain thickness till this process is continued till the entire model is created. For example, so if the slices of the object, if each slice of the object is 1 mm, then the build platform is going to move down through a distance of 1 mm in each step. This is how the build platform is going to lower down till the completion of the final product. So this is how the binder jetting process is going to work. So here the 3D model that is obtained will be having lesser mechanical properties, because so here we are going to manufacture the product by binding the powder material. Due to that, the mechanical properties are lower. So the parts which are manufactured by binder jetting process is not used for the structural parts. And also this process is fast and it is a simple process wherein we are going to glue the powder particles together in order to construct the 3D model. The next process is material extrusion process or fuse deposition modeling process. Here the model manufactured by this process will be having higher mechanical properties than that of binder jetting process. So in a binder jetting process we were using the powder material and then we are gluing the powder material with the help of binder, and we are going to create a model by laying the material step by step till the completion of the 3D model. Here in material extrusion process we are going to get a better mechanical properties. Here we are using the material in a solid state. That is, here in order to make a 3D model we are going to fuse the metal, that is we are converting the solid material to the liquid material, and then we are depositing the material in the form of layers with the help of a nozzle. So by this process the mechanical properties of the material will be higher when compared with the binder jetting process. So in order to increase the mechanical properties, the only thing is that whether the different layers are fused or there is any tight bonding between them or not. Depending upon the bonding between the layers, the mechanical properties are changing. So this is the diagram of material extrusion process. Here we can observe that there is a metal spool, which is a metal. The metal is wounded in the form of coil, and then we can observe the heating element in the this can be observed by red color, and below this heating element there is a nozzle by which we are depositing the material onto the build platform. So here in this process we require the supporting material in sideways, that is in a vertical direction. As usual, the build platform can be lowered down and it can be made to move in a two different direction. The principle of this is that the solid material from the material spool is going to be drawn with the help of rollers. You can see the rollers, that is two rollers which are present in this particular element. So the two rollers is going to draw the solid material, and after drawing the solid material it is sent to the heating element, wherein the solid material is going to be converted into different phase, that is from solid to the liquid phase. When the material turns into the liquid phase, it then passes with a constant pressure from the nozzle. So in order to create the pressure, we are going to use some of the elements there in order to force the material out of the heating element with the help of a nozzle. So the nozzle which is present here can be moved in two different axes, that is x axis and y axis. So this movement of this particular nozzle is dependent upon the data from the STL file, that is according to the model that is designed. This particular head is going to move in x direction and y direction. Here, based upon the data, we are going to deposit the material onto the build platform. Say that is 2 mm of material is deposited on the build platform. After depositing the 2 mm of material on the build platform, Then the build platform is moved downwards through a distance of 2 mm. Then again the head is going to feed the material on the layer that is already laid, that is on the first layer. After laying the second layer, this build platform is again lowered, and then the material is going to be deposited again for a thickness of 2 mm. This is how the entire object is going to be built in this particular material extrusion process. The next process is powder bed fusion process, or it might be called as powder bed sintering process. Here in this powder bed sintering process, we are going to use number of metal, or it may be the alloys, or it may be the plastic powders in order to manufacture the 3D products. So here in this process is going to work on the principle that some of the powders can be hardened by heating. This is the technique what you are going to use in powder bed sintering process. So that is, I have said that the heat source, how we are going to apply the heat source. So there are number of sources of heat. So either we can produce the heat with the help of laser light, or it may be by the passing electron beam in order to cure the powder material. Here this process doesn't require support structures in vertical directions. This process is same as that of previous process, but here we are going to use the powders which can be hardened by heating process. That is, this is a diagram of this particular process, that is fusion process. Here in this process, a layer that is either it may be 0.1 mm or 1 mm thick of material is spread over the build platform. After that, the selective laser sintering machine preheats the bulk powder that is spread onto the build platform, and next the laser is going to fuse the first layer that is deposited on the build platform, and then it is going to cure the first layer, that is powdered layer. After this process is continued by laying another layer, and the light is passed again to harden the second layer. After this, the process is going to be repeated till the entire model is created. So here in this process, we are going to use the number of heat sources from electron beam, or it may be by laser light. So the model that is created by this process is not having the structural properties, that is mechanical properties are low. And also this process is relatively slow. Hence, depending upon the applications, we are going to use the different process of additive manufacturing.